Okay, guys, last video kind of ended abruptly. It wasn't a call about a cruise. It was a call from a doctor, so I thought I needed to take it. I don't know whether I told you guys or not. I was really sick last week, and we don't know what was going on other than ran a pretty big fever for most of the week. So I figured I needed to talk to her. So anyway, the cost of making, oh, just finished problem number 3. So I want to go ahead and finish problems 4 and 5 and some more, okay? So the cost of making 20 radios, let me put this up a little bit so I can get a sheet of paper and actually work the problem for you. All right, so the cost of making 20 radios is $6,800, and the cost of making 50 radios is $9,500. The relationship is linear. That's cool. Radios are sold for $225. So radios sold for $225 tells me that my revenue function is 225 times Q. Now, the cost function is going to take a little bit more work. So I know that I have the order pair 20, 6,800. And I know I have 50 goes with 9,500. And I just get that from the problem. Those two numbers go together, and that number goes with that number. So that's where I create the ordered pairs there. Now, what I would do here is I would use the calculator, and I'm going to use this calculator. Let's keep this where I need it. All right, so I'm going to use this calculator now because I know there are some of you that has this operating system. So I'm going to go to Stat, go to Edit, and I have some information in there I need to get rid of. So go up and hit Clear, Enter, and go over and hit Clear, Enter. All right, so my numbers are 20 and 50. And with 20 goes 6,800. And with 50 goes 9,500. Second function, quit. Go to Stat, go over to Calc, come down to number 4 just like before. But in this situation, we don't put L1, L2 in a list. We have to enter those manually. So I hit my left parentheses. And then I go second function L1, which is right there. Hit my comma. Go second function L2. And then close it up. Hit this. I see that my A is my slope, so my slope is 90. I see my B as my intercept. My intercept is 50. Oh, 50, shoot. Let's try 5,000. So 90Q plus 5,000 is the cost function. Now let's see what the question is asking us to find. It says how many radios must be sold to realize a profit. So that tells me I need to create my profit function. So profit function is easily found by taking the revenue minus the cost. The most basic fundamental relationship, I think, in business mathematics, that how much you make is start out with how much you your total revenue, take out your cost, and that gives you a profit. So revenue was 225Q minus 90Q plus 5,000. Now, guys, you want to get the problem wrong, do that. You're going to get it wrong. This cost function has to be the whole thing. This negative sign applies to the entire cost function. So you have to use either parentheses or brackets or braces to make this happen. So it's just going to take one extra step, nothing too crazy. And 225 minus 90, I can do that in my head. Some of you can too, but just in case you can't, you see it's 135. All right. So guys, we have a profit function, but we need to see when is our profit $250,000. So make sure I get the right number of zeros there. So guys, obviously I'm going to add 5,000 to both sides. So I'm going to have 25000, right? Yeah, equals 135Q. So I'm going to divide both sides by 135. So Q is going to be the number closest to 255,000 divided by 135. So we're going to say 1889. All right, easy problem. Guys, again, that's just something you got to come in here knowing on midterm day. All right, use algebraic methods to find the exponential function in the form f of x equal a times b raised to the x power. We've seen those before, where f of 2 is equal to 0.8 and f of 4 is equal to 0.128. So I know that I have the order pairs 2, 0.8, and 4.128, and these things have to be in the form y equals a times bx. I'm sorry, y equals a times b raised to the x power. Now, I told you a hint many videos ago, start with the biggest number. Well, this is kind of weird because which is bigger? 0.8 is bigger than 0.128, but 4 is bigger than 2. Well, what I mean by that is let's start with the x that's the biggest. So with this one, I know that my y is 0.128. I don't know my a, I don't know my b, but I know my x is 4. Work with this one. I know my y is 0.8. I don't know my a, I don't know my b, but I know my x is 2. Now I can divide both sides and create that. So on the left-hand side, let's see if this turns out to be something nice, and it does. And well, that's the left-hand side. These a's will cancel. And what do I have? I have b to the 4th over b squared. Guys, remember when I have b to the m power over b to the n power, I have b to the m minus n. So 4 minus 2 gives me 2. So I have b squared. I'm going to take the square root of both sides. Or sometimes this may be b cubed, b fourth, b whatever. I need to have the option of raising this to the 1/2 power. And I've given you many examples previously. This is not something that I'm just throwing at you today. I gave you examples. So b squared is easy because I can take the square root. But if this had been b to the 5th taking the fifth root in your calculator is hard to put in. But I could take the fifth root here and raise it to the 1/5 power, which is easy to put in your calculator. But I'd have to take this side over here, raised to the 1/5 power too. But I don't have that. I've got kind of cool stuff here. I got just b squared. So I'm going to work this one over here because it's more general. And this works out nicely over here for b squared. But again, if that was b cubed, b to the 4th, b to the 5th, b to the 6th, b to the 7th, this over here is going to work much better. Nevertheless, power raised to a power we multiply, so we have b to the 1st power. And over here I have 0.16 raised to the 1/2 power. Because I got to put that whole power in parentheses. You got to be careful with the calculator using fractions. And the simplest rule, it doesn't always work, but it works, I'd say 99.9% of the time. Always put your your fractions in parentheses. So guys, I get the answer 0.4. Now I don't know what A is, but I know if I go back and grab one of these relationships, and I'm just going to get the top one, 0.128. So I'm using this one right here. Then I know that I know that my B right here, I know that that is now 0.4. And I have to raise that to the 4th power. So gang, I have 0.128 equals A times 0.4 raised to the 4th power. Let me show you how I do that on the calculator. It's 0.0256. Divide both sides by 0.0256. So A is going to be 0.128 divided by 0.0256, which is equal to 5. So putting it all together, our function, which is in the form y equals a times bx, will be y equals a, which is 5. My b is 0.4 raised to the x power. Now let's put it to the test. All right, let's put this to the test. Let's put this in our calculator. I don't know if you guys... lighting isn't so good. All right, let's put this in our calculator. Let's clear this out. We don't have linear programming now. So 5.4 raised to the x power. Doug, that's not what you want. We want it there. 5.4 raised to the x power. And let's just graph this, the window. What do we want? Well, guys, we have x's from 2 to 4, so I'm just going to go up to 0 to 5. And my y values look like they're the 0.8 to 0.128, so I'm just going to go somewhere between 0 and something small, say 2. I'm going to hit graph and see what I get. If I get a decreasing exponential function. Now, I can go up here and go second calc, value, and I want to check out this first one too and see if I get what I should get. So I'm going to put in a 2 and I get 0.8, which I should. We'll go back up there and do that again, but this time I want to put in a 4, and if my function is true, I should get 0.128, which I do. Okay, so that worked out nicely, as it should and as it will. If you follow the instructions that I'm trying to teach you. Easy for me to say, right? All right, number 6 and number 7. Let's go ahead and try to knock these two out, and then I may pause this video and then start another one in just a second. So, because number 6 is going to take a while. I'll tell you what, let's go on down to number 7. Number 7, let's just knock it out real quick. So you're given a screenshot of 2 graphs, the cost and the revenue function. Which line is most likely the cost function, A or B, for credit? You must briefly explain. Well, guys, if you think about our revenue function is always some R of Q equals like 200 times Q. It's the price that it's sold at. But notice the y-intercept is 0. A cost function is usually a marginal cost plus a fixed cost. This thing always has a y-intercept, doesn't it? Which tells me I come up here someplace and I start at my fixed cost, and then I have a marginal cost from there on. My revenue would be line A. Now guys, when we have x's down here, notice that our cost is above our revenue. So from here to here, we're losing money. But choose a point beyond this point right here. Everything over here, we're making money because you choose some point like this one. I come up, there's my cost, there's my revenue for that x, and you can see that the difference between those two values is indeed the profit. So you can find the profit directly from the revenue and the cost function. I think that would be kind of worth actually pointing out before we get into this. Let's go back to something that we saw earlier, which was this problem right here. Cost of making 20 radios. I know I've got to work here someplace. Yeah. So let's grab the calculator and just just see how that works out. So guys, I can put the cost function in, which was or the revenue. I'm sorry, which is 255x. 225x. And the cost function was 90x. Now we use Q's, but your calculator doesn't handle Q's. So it's 90x plus 5,000, right? Now, I got to get my windows set up correctly. Now, notice that my values for this problem were 20 radios and 50 radios. And then actually my answer ended up being around 1,900 videos. Okay, so I'm going to run this thing from 0 out to about 2,000. And I want my Y to, let's see, go from 0, and I think my profit was, well, my revenue would have been, let's see what happens with a Y of, say, 15,000. I don't know if this is going to work or not. Let's see what happens. It was absolutely horrible. So 2,000, I'm going to have a revenue, let's see, of 2,000 times $225. So I need to go out to 450,000 or so. So let's see what happens there. Much better. Now you can see that if we zoom in down here, let's zoom in way over here. And let's see, you can see that our break even is going to be, let's see what happens. Our break even is going to be probably somewhere in there. Yeah, we break even pretty quickly. It doesn't take many units to break even, but it takes a lot of units to create 255,000 profit. So anyway, guys, what I can do is I can go back to what I did. I can go back from to 0 to 2,000, and go back to 0 to 2,000 times 225. That should get us pretty close. All right, so let's go back to this. Now let's go put a quantity in, and let's just put a quantity in of 1889, which was the answer. That's where we created 1889 is where we created a profit of 250,000. So when I go to that, I can see that my revenue is 425,025. My cost is 175,010. So I just wrote those two numbers down right down at the bottom. So if I take 425,025 minus 175,010, notice that I get something invalid. What did I do wrong? Oh, I can't do it there. Got to do it back in the home screen. So 425,025 minus 175,010. So I get right at 250,000. Now, guys, remember when the reason we're off a little bit, when I actually worked this problem way back when, remember it came out to 1888 point something, so we rounded up. So we're going to be off a little bit of the 250,000, but not much. All right, sorry for that tangent. I know tangents drive people crazy, but I figured that was something that's definitely worth covering. Hint, hint, hint. Let me get this thing focused here. All right, guys, let's work the linear programming problem, and then we'll end this video. So it says an office manager needs to purchase new filing cabinets. He knows that Ace cabinets are $40, requires 6 square feet, and holds cubic feet of files. On the other hand, Excello cabinets cost $80, requires 8 feet of space, and holds 12 cubic feet of files. His budget permits him to spend no more than $560 on file cabinets. And the office has room for no more than 72 square feet of cabinets. The manager desires the greatest storage capacity within the limitations imposed by the funds and the space. How many of each type of cabinet should he buy? Well, that tells us right there we want the greatest storage capacity. So we want to maximize the storage capacity based on certain conditions. So we know this is a linear programming because we're trying to find a value of the biggest or the smallest. Maximize or minimize, greatest, least. We want to find the greatest or the maximum storage based on these other imposed deals on funds and space. Well, guys, this is going to be an interesting problem. Let's work it out. Very realistic, something that an office manager would run into, I think. So the very first thing that I want to do always is define my variables. So I'm going to let X be what? We want the greatest storage. So what I'll do is let X be the number. Let's see, what do I want to do here? No more than 72 square feet of cabinets. So greatest storage, so I'm going to need X to be the number of ace cabinets. And Y is going to be the number of Excello. I've heard of ace cabinets, I do believe. I don't think I've ever heard of Excello. Okay? First thing I'm going to do is I'm going to find the maximum for Z. Now I'm trying to maximize storage. And I can see storage is 8 cubic feet for each ace cabinet. And for each Excello, it holds 12 cubic feet. All right, subject 2. Certain constraints. All right, so I've got to pay $40 for each. Well, I don't have to pay it, but $40 for each ace. We'll circle that. I have to pay $80 for each Excello, but I can't spend any more than $560. I know that the ace requires 6 square feet. And I know the Excello requires 8 square feet. But I don't have room for any more than 72 square feet. Since X and Y are the amount of cabinets that I buy, I know that both have to be positive, so X and Y have to be greater than or equal to 0. All right, so yeah, the first thing I'd want to do, again, because it helps me out in the problem, is get my X and Y intercepts for the first and for the second. So guys, for the first one, cover up the Y, so I get 560 divided by 40. So I get 14. Staying with the first one, if I want my Y-intercept, I cover up my X. So I have 560 divided by 80. 7. Come down to the second, my X-intercept is when I cover up my Y. So 72 divided by 6. It's 12. And to get my Y-intercept of the second, I cover up the X. And I think we all see that that's 9. Guys, that's going to help me once I get my feasible region. And it's going to help me get my feasible region because it's going to help me set up the calculator to where I graph it at the best viewing window. So guys, next thing I'm going to do is I'm going to take this 40x and I'm going to do what we always do. So negative 40 over 80, I see that that's negative 1/2. Hopefully you do too. So gang, there's one of them. Let's go get the other one. Now, what about this negative 6 over 8? Now, I see it as negative 3/4. But let's say you don't see that. Let me show you a trick. You can go negative 6 divided by 8 And as long as that's a decimal that doesn't like go on like 0.666666, you can use that. And that's what I'm going to do here. There's a trick that I can show you. I think I'll leave that for another day. I'll make sure you don't need that on your exam. All right, gang. Let's graph this and get this problem behind us. So I'm going to graph these two. So top one I have again put parentheses around and negative 0.75x plus 9. Now, if you do the way I do, make sure you delete everything out in the end, because that will cause problems if you don't. So, guys, it's going to be less than. All I'm doing is hit the Enter key. Now, let's go down to Window. Now, let's think about what should our x's be. Well, let's look at our x-intercepts, 12 and 14. I'm going to go just one above the biggest. Go to our y-intercept, 7 and 9. I'm going to go one above the biggest. Guys, if I do that, I always get a good picture. Always will. And I'll always get a picture where I can easily come up with the corner points of the feasible region. All right. So speaking of the feasible region, let's get that going. Okay. All right, gang. So the feasible region is going to look like this. It kind of comes out and then it kind of drops down. Points are easy. Well, this one's easy. Let's think about these x and y intercepts according to our pictures. When I look at this picture right here, I look at my y-intercept. There's my biggest one. There's my smallest one. 7 and 9. There's 9. There's 7. I know this point is 0, 7. I know it is. I come out here and look at my x-intercepts. There's my smallest. There's my biggest. My biggest is 14. My smallest is 12. That's 14. That's 12. I'll let my calculator find the other. It's really simple. Second function calc, just like before. Come down to intersect. And guys, just keep hitting enter. You don't have to do anything fancy until you see intersect come up. And it looks like to me the intersecting point is 8, 3. All right, now I'm going to go back to my So I'm going to look at my table here. So my points are 0, 7, 8, 3, and 12, 0. My objective function is 8x plus 12y. So guys, here guys, I have 8 times 0 plus 12 times 7, that's 84. Here I have 8 times 8 plus 12 times 3. That's what, 36 times 64 plus 36, 96, that's 100. And here I have 8 times 12 plus 12 times 0 equals 96. So guys, your best bet here with all the constraints you have is to purchase 8 ace cabinets, 3 Excello cabinets. You can just tell those are good from the name, can't you? No. And your maximum filing space is 100. What was that given in? That was given in cubic feet. So given in feet cubed. All right, so we jumped around a little bit here. Let's go back and answer the problems. This is linear programming. What are the variables? Well, we let x be the number of ace cabinets, y be the Excello. The objective function was z equals 8x plus 12y. Now the constraints were these babies right there. What are the corner points? There are 4 corner points. I gave you 3. There's always another one, 0, 0. Now, and then what's the solution to the problem? Solution's right here. Now, guys, I don't know if you've noticed yet, but it seems like the solution to the problems is always that point right there, isn't it? I don't get too comfortable with that because there are problems I can come up with where your optimal solution is one of these two. So don't necessarily take that for granted in moving forward on your midterm. All right. I'll tell you what I think I'm going to do. I think I'm going to end this video. Next video is going to take a while. So those are the problems we're going to do in the next video. So if you want to work on those before the next video, that's hopefully you already worked on, but nevertheless.